Okay, so the difference on this one between the last sections is that last time we were finding the sine and the cosine given either the sine or the cosine. Okay, so this time they're going to give us a tangent and they're asking us to find the sine and the cosine. Okay, so this is going to be a little bit more complicated. Okay, so I gave you two identities on Wednesday. Okay, the first one that you wrote down in your notes looked like the tangent of theta is equal to the sine of theta over cosine, right? Okay, the other one was Pythagorean's identity, which is sine squared of theta plus the cosine squared of theta equals 1. Okay, so what we're going to do is we are going to use both of those identities to figure out the sine and the cosine. We're going to use both. Okay, so the one that we're going to play with the most is going to be the Pythagorean identity. Okay, but the first thing I have to do is I have to use the tangent identity and kind of manipulate it a little bit so that it's in terms of a sine over a cosine. Okay, so on my tangent identity, the first thing I'm going to do is simply solve for the sine. Okay, so if I'm looking right here and I'm going to solve for the sine, what would you do algebraically? Multiply by the cosine. Okay, so would you say that the sine will equal the tangent times the cosine? Everybody agree with that?
Yes.
Okay, good. Okay, so now what I'm going to do is I'm just going to do a substitution step. Okay, so I'm going to take this, let's call it this red piece. Okay, and I'm going to put it into the sine of this Pythagorean identity. Okay, so it's a substitution.
Oh.
Are you ready? Okay, so it's going to be, instead of writing sine, I'm going to write the tangent times cosine squared plus the cosine squared is equal to 1. Okay.
Why do we have to keep writing theta?
Yeah.
Theta is like the x. So it's a variable. It's a variable that's identifying an angle. So it's like you can't just get rid of an x in the equation. It still is it's a variable. If we don't have it, then we have a number technically instead of an equation. Okay, so at this point, this is the equation that I'm going to use. So you might highlight this in your notes. Okay, and this is the equation that you're going to basically use to solve these last problems. Okay.
Always sine.
Okay, we'll go back and find sine later, but technically we could have solved this either way. We could have found the cosine off of the tangent piece and then replaced the cosine within the Pythagorean identity and had an equation in terms of sine. Yeah, because if you solve for sine off of the tangent equation, you would have to multiply by cosine, and then you'd have to divide by the tangent. So cosine would be sine over tangent, and you'd be working with fractions. Yeah. So this way is just slightly easier. Okay, so now what I'm going to do is I'm going to now use the information that is given to me within the problem. Okay, so the tangent is negative 2.327. I'm going to place that within my yellow equation down there. Okay, so another substitution piece, now using information that was given.
Just notice.
Okay, so at this point, it's now going to become straight up algebra. Okay, I am just going to solve for cosine. I can solve an equation where I have one trig function. Okay, so how would you start to simplify this algebraically?
You can just subtract the cosines.
We can do, first let's get rid of parentheses.
So if you want to square everything first.
So let's square stuff first. Perfect. Okay, so what is negative 2.337? Did I write that number down? Oh, sorry, I wrote that number down. Wrong. 327, my bad. Looked funny. Okay, so can you square that? You get what?
Negative 5 point.
You mean positive, right?
No.
If you square a negative number, you get a positive.
Well, somehow we still got negative. So
Yeah.
maybe the calculus is wrong?
You use parentheses, right? It's 5.415.
Okay, so it has to be positive, right? Because you know
Oh,
that if
yeah,
you're
right.
squaring a negative, it's going to be positive. So you have to be smarter than the calculator. The reason that you're getting a negative on the calculator is because, well, it's doing an order of operations. Okay, so if you type in negative 2 squared, it's going to tell you the answer is negative 4. Okay, and the reason is it's going to do your exponents first and go 2 squared and then take your negative. Okay, so you have to know, I know that I'm going to square a negative number and get a positive. So just be careful about that. Since I have a cosine being squared, I'm going to rewrite this as cosine squared. And the rest of this is going to stay the same. Okay, now what can we do?
Add a multiplication sign.
What do you mean by that? Add a multiplication sign. Oh, like right here? So that made you feel better? Okay. Do you guys see that we have like terms on the left-hand side? We have like terms. We can combine the two cosines together. So if I have 5.415 plus one more cosine, how many cosine squareds do I have? Well, 5.415 plus 1. Go ahead, Jade.
Why is the theta squared 2?
Because it's just a cosine. So it's like a cosine of theta. If I square it, I have 2 cosines. So it's like, I know what you're saying.
Well, yeah,
So
it's like
this is
difference
kind of
is-
what you missed yesterday, or whatever day that was. Okay, so if I have a cosine that's squared, right? That's equivalent to like cosine times cosine, right? Okay, well this notation is written as the cosine squared. Those two things are the same thing. And why they put it after the cosine, I have no idea why they do that. I think the reason they do that is because maybe people would go cosine theta squared and think, oh, I'm just only squaring the theta and not the cosine. So that's just a notation of that scenario. Does that kind of make sense?
Yes.
Okay. Okay, so see, I have 5 cosine squareds, 5.415, plus 1 more cosines.
6.
So, okay. I know this is a mind blow. Are you ready? I'm going to write an example of what you see. We have 5x squareds plus x squared. How many x squareds do you have?
I figured it out.
You're just adding it, right?
Yeah.
Okay. I know it's hard to see because we're working with trig, so it's hard to identify. Okay, now what would you do algebraically to isolate the cosine?
Divide.
Good. Okay, so the next step is now to divide by the 6.415. Okay, so I'm going to have cosine squared is equal to, can somebody tell me what 1 divided by 6.415 is? 1558. 59. Okay.
All
right. Wait, what?
Because it's 0.1558, so it'd be 1.15.
So 156. Oh, sorry. It could have been me.
Where'd the
Okay.
4 come from?
Yeah, it's still 5.
No, 5, 6.
What? Oh gosh. Okay. Good now?
Yeah.
All right. So last step, how do I get rid of the square?
Square root.
You square root it. Okay. So what is the square root of 0.156?
A number?
Yep.
I don't know if I calculated wrong.
0.35.
0.395.
395. Okay, now technically I would need a plus or minus since I'm solving an equation, right?
Yeah.
Okay, but I know that I'm working with trig functions and I'm going to go back to the original information that was given and say, okay, well, if we're working between pi over 2 and pi, which quadrant is that going to be in?
Second.
The second. So if we're talking about the second quadrant, is my cosine going to be positive or negative?
Negative.
Negative. Your x's are negative in the second quadrant, so we're going to call this just negative. Okay, so success, we found the cosine. Now we got to find the sine.
Can't you just plug that and the tangent in and find something like that?
Yeah, actually, I didn't even think of that. The way I was going to do it was by using the Pythagorean identity the way we did the first 4 problems or 8 problems of the assignment. So let's check and see if your method works exactly the same, and then you have 2 possible scenarios. So I was going to go, the sine is going to be, using Pythagorean's identity, 1 minus your cosine squared, so 0.395 squared. What do you get for that scenario?
Minus.
0.918. 0.919. And if we're in the second quadrant, it should be a positive. Okay, so let's see if that gives you the same thing. I didn't think about using the tangent identity. So the tangent identity, let's see if I go back up here, would be the sine would be the tangent times the cosine. So if we have a tangent of negative 2.327 times the cosine, which we found to be negative 0.395, do those 2 numbers multiply to 0.919? They do? 0.919. Hey, look at that. So 2 different ways you can potentially find the sine. Nice, good thinking. I didn't even think of that. Good. So should we do one of the problems on the assignment, and then you'll be good to go? Okay, so everybody have that assignment, by the way? Okay. So we'll start on number 9. Sore? Okay, so what is the equation that I'm going to use to start this out?
Tan equals sin over cos.
Okay, so can I go and just kind of jump a little bit and go to that yellow one that I highlighted? Is that all right if we go there? So it said tangent times the cosine squared plus cosine squared equals 1. So just going straight in the Pythagorean theorem, already doing that substitution step. Okay, so where do I go from here with the given information?
Plug the tangent in and square it.
Right, good. So 3.966 times the cosine squared. Okay, so what is it? 3.966?
15.73.
15.73?
Yeah.
Positive though, right?
Yes. Yeah, I forgot.
Cosine squared.
And that's going to be 60.
So we add the like terms, good. 16.73 cosines squared.
Weird.
Okay, and then what do you do? Divide the 16. And pull this up. So 1 divided by that 16 is 0.509. Okay, and then last step. Square root it, yeah, good. So the square root of 0.059, 243. Okay, so last thing we have to do is decide if that is going to be a positive or a negative value. If we're between pi, or pi over 2 and pi, that's in the pi over 2 and pi, which quadrant are we in? Yep, second. Okay, so if we're in the second quadrant, is that going to be a positive or a negative x?
Negative.
Negative, good. So we'll have a negative cosine. Okay, so now how do you want to go about finding your sine? Should we use Pythagorean identity or should we use the tangent identity?
Tangent identity.
Tangent identity, I like it. Okay, so the sine is going to be tangent times the cosine. So if we plug in the information that was given, negative 3.966 times what we just found of negative 2.243, you get
0.964.
964. Okay, good. And is our sign positive or negative in the second?
Positive.
You do get different answers? Oh, because of the rounding. It will be slightly different. If we used exact values all the way through, it should be equivalent. But every time we round and use a rounded answer, they're going to be a little bit different.
So what's I guess it's more of a real world situation, but how far would you usually go? And like,
Usually you go to 3 decimal places. I mean, if you're rounding. If you can go about doing it without rounding by like as you keep going, keep using the answer from above instead of typing in the numbers, that's going to be more accurate. So the less typing you do and just using the answer from above, the more accurate your answers will be. All right, you guys good with this? Finish this off on your own? Not too bad? Okay. Uh-huh.